Okay, problem number 16 is the de Broglie wavelength of a tennis ball of mass 60 gram moving with a velocity of 10 meter per second is approximately equal to, in which range is coming, we have to find out. So first given quantities I will write, students. So mass is equal to 60 gram. So this is 60 gram, this is 60 multiplied by 10 to the power of minus 3 kilogram. In SI unit you have to convert first. Then the velocity is equal to 10 meters per second. Then the Planck's constant can be taken as 6.6 into 10 to the power of minus 34 joule second. Okay, students. Now the de Broglie wavelength lambda is equal to h divided by m into v. So this is equal to 6.6 into 10 to the power of minus 34 divided by mass into velocity. So this is 60 into 10 power minus 3. So this can be written as 60 into 10 to the power of minus 3 into 10. Velocity is 10 meter per second. So this is 10 power 10 power 1. So minus 3 into 1 can be written as 10 power minus 2 also. So this is now equal to 6.6. So 6.6 into 10 to the power of minus 34 divided by 60 into, this is, I said, 10 power minus 2. Okay, so we can write this lambda is now equal to 6.6 into 10 to the power of minus 34 divided by, now this is 60 into 10 power minus 2 can be written as 6 into 10 power minus 1 also. So this is 6 into 10 to the power of minus 1. So that this is 6.6 divided by 6 into 10 to the power of minus 34 plus 1. So this is 6.6 divided by 6 is what? 1.1 into 10 to the power of minus 33. Therefore lambda is of the order of 10 to the power of minus 33. So very simple, now we have got the answer. So which of these 4 ranges now the wavelength is coming is the option A. So option A, therefore option A is correct. So this is in the range of 10 power minus 33 and the unit is meter. Okay, students.